Alright, so here in this particular video, there's a crash test. It says here a car of mass 1260 kilogram collides with the wall. It is initially moving at a speed of 16 meters per second, and then it hits the wall and then rebound at a speed of 2.1 meters per second. Alright, so let's go ahead and do part A, B, and C. Part A wants us to find the impulse caused by the collision. So to find impulse, you have to do change in momentum. So here I for impulse, delta P here for change in momentum. So I'm just going to break it up into PF minus PI. Here I can break up PF into MVF minus MVI, and then from there I can just plug and chug. The mass here is given as 1,260 kilograms. The final velocity, VF here is final velocity. In the diagram, the 2.1 meters per second is pointing to the right, so that'll be a positive 2.1. And then here the function itself is minus, so I'm going to carry that minus sign down there. And then the mass once again is 1,260 kilograms. And then VI is negative 16 meters per second. Here I highlight the negative sign for 16 here because the diagram has the car initially moving leftward at a rate of 16 meters per second. So even though the diagram here only has 16 meters per second, the 16 meters per second has an arrow pointing leftward. And because in momentum you need velocity, it's important that you recognize you need the negative sign there when 1 is not given to you. So even though the diagram only has 16 meters per second, I know better. It should be negative 16 because the function requires velocity, and velocity is a vector, so you need the direction. All right, other than that, we can simplify things. Here's a negative sign, and then times it by another negative. That'll make it a positive sign. So therefore, if you simplify the first term, you get 2,646. And then when I highlight that positive sign, because again, the function itself is minus, but the initial velocity is minus. So a negative times a negative makes a positive. So you end up adding these two values together. So the impulse experienced by the car during the collision with the wall would be a positive 22,806. Okay, you need a positive sign there because impulse is a change in vector, so it has to have a direction. All right, let's go ahead and do part B. Part B asks us to find the average net force exerted on the car during the collision. So here, to find the average net force, I would just simply do the other variation of impulse. Impulse can also be calculated by simply taking the force times the change in time, or the time of contact. All right, we already calculated impulse from part A. So really to find F average, algebraically speaking, I'm just going to go ahead and divide both sides by delta T. So here I have I divided by delta T, which is equal to average force. And then we already know I from our previous work in part A. I just carry down the 22,806 there. And then I'm going to divide it by the 0.1 second, because in the problem, it says if the collision lasts 0.1 seconds. So it makes things pretty easy. So if you punch 22,816 divided by 0.1, really you're just adding a decimal or a zero to your numerator. All right. So therefore the answer is going to come out to be 228,060 newtons. And that is our answer. And it says force. It didn't use the phrase magnitude. So in this case, the car is moving leftward. So the wall is going to push rightward in order to decelerate it and change its direction. So the answer here needs to be a positive sign because the wall is pushing rightward. Okay. All right, and then on that, part C asks us to find the change kinetic energy. Change kinetic energy is KEF minus KEI. Here I've chosen to just write 1/2 m and then in parentheses VF squared minus VI squared. You can distribute it out if you want. It doesn't really matter to me, but I'm just going to go ahead and plug and chug. Here 1/2 times m being 1,260. I left the units out here. The final speed here is just 2.1 square because the diagram said so, minus the initial speed. Once again, we're doing KE, so VI here just stands for initial speed. The initial speed is simply 16 because it's moving to the left at 16, but we're just going to use speed, so it's just 16 square. And if you simplify this on your calculator, 2.1 square minus 16 square will give you a negative 251.59. And then as you can see, if you simplify everything, it'll give us a negative value. So the change in kinetic energy will be a negative 158,502 joules. All right. It's negative because energy has been converted into damaging the car and stuff like that. Okay. All right. And that is it for this one. So the answer to C is that. All right. Stay nerdy. Don't be whack.